Okay. In the previous class, we are done with the industrial part. Now we have been left with two topics, that is from manufacturing part, and that is metrology and inspection, and another is material science. And these two are important. Though these are important, these carry very less weightage in gate examination as per the previous year question paper pattern. But I'm not sure whether the same pattern, the weightage, the weightage that gate exam follows, might not be or may not be followed by the HCL examiners. Okay, they might set up question paper in such a way that they might give good weightage to this as well. But generally what I've observed is that very less number of questions will be asked, and that too some easy questions will be asked. Okay, so what I'm going to do is that I'll give you brief introduction of both metrology and inspection, and mainly I will concentrate on the tolerances and fits. That is very important, and let rest of the surface measurements and all the things are like we'll just scan through the slides and then we'll go to material science. Okay, fine. So what is metrology? Metrology is nothing but it's the Am I audible? Yeah. Metrology is the science of measurement, precision, and accuracy. That is what is important. These three terms are very important. Measurement. How are you going to measure? Right? How are you going to measure? It's very important. If you want to measure a linear length, right? Then you have to have a scale, right? You have to have something like vernier caliper for diametrical objects, cylindrical objects, right? If you want to measure the diameter of a cylindrical object, then obviously you will be able to measure it by using screw gauge or vernier caliper, right? And I want to know what is the standard. Okay, I will in my scale I'll have some readings. I'll say this is 1 meter or this is 1 centimeter. How are you sure that is 1 centimeter? Because we have some standards. Some standards have been set up. We basically this kind of, if you go to any physics textbook, in your 10 plus 1 and 2, you will see the first chapter to be units and measurement, isn't it? So they'll discuss what are the different type of units and then how you're going to measure them, right? The same way, there are some techniques to measure some dimension or geometry, right? And then now this precision and accuracy are belonging to the specific workpiece. If the workpiece is precise, then it means something. If the workpiece is accurate, then it means something. So there is a good difference between precision and accuracy. That's what we are going to discuss. Okay. So let's see. That is what is measurement is method of comparing quantitatively an unknown value with a predefined standard. Standard is very important. What are the standards that you are going to use? Are you going to measure it in centimeters? The systems are different, right? The SI units you can use, right? All these things are different unit systems. You can use whatever you want. If you want to measure weight in terms of kg, okay. If you want to measure weight in terms of pounds, it's okay. Based on your preferences, you can use certain standards for that. Okay. So the good difference between precision and accuracy are here. See, precision represents the degree of repetitiveness. Okay. So let me read the other one also. Accuracy. Accuracy refers to the degree of closeness of measured value within true value. Okay. Now that we know, we have read both of them, let me explain both of them very clearly. Okay. So let us assume that you are trying to manufacture, okay, let me take the pen. Okay. I want to manufacture this rod of some length L and some diameter T. Okay. And this is your design. This is what you have designed, right? And these are the actual values, and these are the design values. Now you have to manufacture some 10,000 of cylindrical bars with this diameter and L. Let us assume that. Now, once you manufacture, then you do the measurement. You measure diameter values, you measure length values for each of the items that you have manufactured. Can you say that you pick any one out of this, and you just check whether the diameter and length are maintained or not? Are you sure that it's going to maintain the same diameter and same length that you have designed for? Yes or no? Is it going to maintain the same design value in the actual value? So this is what is actual now. Guys, what do you say? Not at all. Not at all. True. Why? Because you say that the diameter is 10 mm. You said that diameter is 10.00 mm. You said, but it can be 10.0002 mm, right? It can be the part mistake, or it can be the measurement mistake. The measurement equipment is mistake, is having some defect in that. So we are not sure about that, right? So like that, if you are taking all the 10,000 item values, actual values, let's say you have measured it, you have inspected it, and you measured it. Now, what is repetitiveness? Okay, let us assume that your diameter actual value is 10 mm. You want to manufacture 10 mm, and if you are measuring it, so first object out of 10,001, it gave you 10.01. Second one 10.01. Third one 10.01. 10.01, like that. Even though it is not equal to the actual the design value, the actual values are having same repetitiveness, right? So if you are trying to maintain that repetitiveness, even though you are wrong, that consistency, what I say, right? It's like cricket. Let's say some batsman is there. Any match he plays consistently, you are sure that he'll give you 50 runs. That is consistency. So repetitiveness is very important. So the degree of repetitiveness, how many times you are repeating the same value, that is what is your precision. And accuracy is nothing but how close you are to the true value. So how close you are to the true value? If you take this one, your close of 0.01 is the error. If you are having another object, the fourth object is 10.00001 mm, let's say. How close you are? This fourth object is very close to the actual value. So how close you are to the actual value, to the design value or the true value, is known as accuracy. Did I make the difference between accuracy and precision clear? Yes or no? Guys? Yes, very good, very good. Now, so the dimensional metrology, so this and all, let's leave. So now the important thing is that the width, depth, angles, and all other measurements must be produced and measured accurately for a machine to function expected. Okay. And active inspection is one of the way you can inspect online, in the sense like even when the manufacturing is going on, it is live. It is keeping on doing its manufacturing, it is doing machining, or it is doing something else. Lively, you are trying to measure it. You're just on real-time measurement you're doing. That is what is your active inspection. And passive inspection is that once you're done with the product, then you have taken the piece, or you have taken the workpiece out of your machine, and then you're taking it to a department separately, to the inspection department, and then you're trying to measure it, right? That is what is your passive inspection. Okay, fine. Now this is very important. I already told you what is this distribution. Normal distribution, right? This is normal distribution. So here any manufacturing system follows this kind of, any manufacturing system operations, anything, because everything is random. And if you try to plot any parameter and then their frequencies, like what I'm saying is that, like you want to manufacture 10 10 diameter, 10 mm diameter, then you get different values of diameters. You might get 10.01, you might get 9.8, 9.9, 10.1, you get different diameters. Let's say 10.1 is repeated for sometimes, frequency. 9.8 is repeated for sometimes. 10 is repeated for sometimes. Like that, you plot in x-axis, you plot the diameter values, and in y-axis, you plot the frequency, how many times it has been repeated. Then if you plot all the things, all the available diameters that you have manufactured with respect to their frequencies, what happens is that you get this kind of a curve, bell curve. In that, the important thing is that this is the mean value. Mean value is, in this sense, is nothing but the true value or the design value. And this sigma is the standard deviation, that is what is your consistency. So the precision is with the sigma, accuracy is with this, the mean value. So if your value is how close, if your value is exactly this, then you're very close. If your value is little away, then you're not close. And the spread, it is like if your normal distribution curve can be very spread like this or very sharp like this. More spread means more standard deviation, right? More standard deviation, right? More standard deviation. More standard deviation means your consistency is not good. Your repetitiveness is not good, right? Less standard deviation means your repetitiveness is good. Okay. So sometimes what happens, your actual value, your actual value is this, and your true value is this. So there is a difference. This is what will give you the accuracy. How far your point is away from the mean point or away from the true value. That gives you the accuracy. Okay. So to explain that this concept, we'll go to this. Anyways, like this graph only, I'm just rotating in 90 degrees. I'm getting like this. Okay. Same thing. This is also normal distribution. Okay. Just I'm rotating 90 degrees. Okay. Please try to understand that. Okay. Now I told you already that mean value is nothing but your true value. And sorry, the mean value is your actual value. I'm sorry. Mean value is the your actual value. And this is your targeted true value. Okay. So if this is your actual design value, that is 10 mm. And let's say your mean value of all the dimensions is giving out to be some 10 point, sorry, it's less, 9 point something, 9.9, let's say. So the difference is what is your error, right? That is what is your error. And in this case, what is happening here? The standard deviation is very, less. Standard deviation is very less. Standard deviation is very less means it is the repetitiveness is very high. The repetitiveness is very high. What is it? Okay, let me see the Nick diagrams. What is that? The spread and all. Let me see that clearly. So this is the precise. Okay. Actually, the diagrams should be like this. Let me draw. The diagrams here are confusing. So the spread is more, and this is your actual what has occurred, mean value. And let us assume that this is your true value. As the spread is more, it means that it's not precise, right? It is not precise, and as the actual value or true value are very much near or almost near, hence it is accurate, right? That is what is this diagram. And also, if you see the next diagram, the spread is less and both are very near. That's the reason why it is accurate and precise. In the next diagram, your spread is less. That's the reason why it is precise. And the mean and target value are very far away. That's why it is not accurate. And if you see, the spread is very high, and the value difference between mean and target also are very high. Hence, it is neither precise nor accurate. Okay, that is what is that. Next. So Please try to understand. This might be a question because sometimes he might give some kind of graph like this, and they might be asking, is it precise, is it accurate, or else if they'll be asking you, manufacturing system will follow in different, what is the distribution, normal distribution, right? Fine. Now we'll go into limits, fits, and tolerances, which is very important uh, for any examination. Okay, in the metrology and inspection syllabus. Okay, so that is important. What is that? It is impossible to manufacture any part precisely to a given dimension. In the sense, it is impossible, right? You want a 10 mm diameter. It is impossible, right? You can't manufacture. You only told not at all. 10 mm you have to manufacture. You will not manufacture. Either you'll go above it or you'll go below it, right? Let's say you go maximum, you went till 10.2 mm. That is what is the maximum diameter that you achieved, and minimum you went till 9.7 mm. The minimum diameter of all the pieces is 9.7. It means that this is what is your maximum minimum value. So this is what you have to set. This is what you have to set. In the sense, this is known as upper limit, and this is what is your lower limit, right? In the sense, what I'm saying is that the upper limit and lower limit has to be set by you. You should say either it can go 0.1 mm more, and it can come down by 0.2 mm. It's okay for me, but it should not cross this range that I've mentioned. That's the reason why we are talking about the lower limit and upper limit. Okay, so what is that? If you see, 30 was the dimension that I wanted to, what you say, have designed. This is your true value, right? But you said that it can go till 29.9, it can go up till 30.2. That's the reason why this is lower limit and this is upper limit. Okay, so that is what is limits. You have to set that. That is your the permissible sizes, maximum and minimum, within which the size of the component lies, are known as limits. It can be classified as upper and lower limit. Okay, and next is tolerance. What is tolerance? Difference between the upper and lower limit. That's it. Difference between the upper and lower limit will give you the tolerance. I will say maximum this much, minimum this much, I'm saying, but what is the range? Range is known as tolerance. Right? The difference between the maximum and minimum limit is known as, or upper limit or lower limit is known as tolerance. That is 30.2 minus 29.9 will give you 0.3. So I can say this object can be manufactured with tolerance of 0.3 in a sense. But in this, if you are saying tolerance alone, you will not be knowing whether it can go 0.3 in the upper limit, or it can come down by 0.3 in the lower limit, or upper limit and lower limit are splitting this 0.3. We don't know, but tolerance will know. So obviously, to know something, limits is very important. From limits, you can calculate the tolerance. Fine. Now, so tolerance is about the total amount of dimension will vary, and the difference between the upper and maximum. I told you already. In tolerances, we have dimensional tolerances and geometrical tolerances. What is geometry and dimension? What is the difference between dimensions? Dimensions is nothing but if you have this thing, this is your dimension, diameter here, this is D is your diameter, dia, and that is what is your dimension. Okay, and what is geometry? Circular geometry. Circular, right? So dimension can also be disturbed, geometry can also be disturbed. Dimension disturbed means what? You expected to have 30 mm diameter, but the diameter was somewhere around 30.01 mm. That is a disturbance in diameter. So you thought of having a circular bar, but it was little elliptical bar like this, right? Circularity is not maintained. So that is what the tolerance is nothing but we have tolerances on dimensional and geometrical. So mostly now in this section we'll be discussing about dimensional tolerances. Okay, so fine. So let's go next. Next is the tolerances we have discussed, but it can be divided into two dimensional tolerances. One is unilateral tolerance, another is bilateral tolerance. What is unilateral tolerance? nothing but your tolerance is one side of your basic size. So from now, I told you, true value, true value, true value, whatever I'm saying, that is what is your basic size. From now, I'm telling basic size in the sense the size that you have designed, that size that you wanted to have, that size that is true. Okay. So now, if you see the left hand side, let me take the highlighter. So if you see the left hand side, 22 is the basic size. Let me take 22 is the basic size, but the tolerance is given on the lower side, right? And if you see, this is the 12, that is your basic size, but the tolerance is given on the upper side. Lower side you are giving 0. And you see angle also, this is what is your basic size, 25.6 degrees is your basic size. Lower limit is this, that is 0.2. You can't go up. In the sense, either you can go upper limit or you can go lower. Both are not allowed. That is what is your unilateral. Dimensions of allowed on one side of the basic size, either positive or negative. Both are not allowed. In bilateral, positive and negative both are allowed. So both sides of basic size are allowed. That is 22 plus or minus 0.2. And in the sense what? It can be 21.08 to it can be 22.02. Both sides is allowed. Basic, what is the basic size? Basic size is 22. Right? So in the in first case, you can either use plus or minus. In this case, you have to use plus and minus. Okay, after the basic size. Fine. That is what is your unilateral and bilateral tolerance. Now let me introduce some important terminology in complete limits, fits, and tolerances. What is that? The first terminology is shaft, and second terminology is hole. Okay. So what is shaft and what is hole? Okay. So generally, in mechanical perspective, shaft is nothing but some kind of cylindrical object, right? And hole is nothing but some kind of space in a cylindrical thing. Generally, hole means every time we assume that it's a cylindrical. Generally, if you are a mechanic, if you are thinking in a mechanical perspective, if you say something hole, then every time our mind will say it is in circular, but hole can be of different size, different geometry also, right? So the hole can be of, this is also hole, but generally what our mind says, this is a hole in mechanical perspective. Generally we will say this is shaft, right? But in metrology inspection, shaft is an external feature and hole is an internal feature. That is what is important. And we are not considering about anything about geometry. Shaft is, so I can have a shaft of like this. This is also shaft for me. I can have a hole like this. This is the hole. Or I can have a shaft of something different dimension like this. This is my shaft. And I can have a hole of maybe this dimension hole. So this is what is external. External dimension is very important. For this, internal dimension is very important. This is internal and this is external, isn't it? So that is what is the difference between shaft and hole. From now, something, if you are saying shaft, it is an external dimension. If something they are saying as hole, then it is an internal dimension. Okay, fine. Now, so now we have to decode this complete diagram. So let me take different ink and explain that. Okay, this one. So if you see this line is your zero line, they say. Zero means the dimension is not zero. Zero line in the sense the basic size, right? And the basic size, generally if you have a hole, circular hole and a shaft, you assume that if the shaft wants to go into that hole, let's say the shaft has to go into that hole. Let's say you assume that this diameter and this diameter should be almost equal, and this is what you have designed. You are designing that this is what is the 30 mm you designed for a hole, and you design the shaft also is 30 mm, right? But with some tolerances, but tolerances you'll put when you're manufacturing, but while designing you'll put only 30, right? You'll use this 30 value only, and then you do something, stresses, all these calculations you'll be doing. I mean that strength of material, mechanical solvents you'll do, right? That calculations you'll do, but you will not use any tolerances there while calculating, right? So that is what is actual. That is what is your basic size, and that basic size line is this 30. It means this line representing 30, for example. Okay. So please do remember. So that is what is your zero line here. This is what is your zero line. That is your basic size. Okay. Now either you can go up and bottom for the hole, right? I can go up or bottom for the hole. So what I'm saying is that this hole what you're seeing is not full hole. It is only half hole. This is the full hole actually, and this is the full shaft actually. Okay, so only half of it is shown here. That is the important thing that you have to understand. Okay, is it clear? Yes or no? Not here. I mean, not in this diagram. Sorry, the diagram what I told here. This is shaft, and this is, sorry, 1 minute. Shaft and hole. Let me draw it clearly before making mistake. This is shaft and this is hole, right? So it can be, this is hole and this is shaft. Okay, so only half of it shown. Half of that is shown. Only actually it is half of it is shown. That is what is this. Okay, the dimensions. Okay, but here I think they have shown full. Here they have shown full. Okay, fine, no problem. But the tolerances they have put it, they have pushed it at the end. Okay, so for shaft, this is the basic size, right? And this is the maximum diameter it can go, and this is the minimum diameter it can go, right? So both are below, maximum and minimum, both are below the basic size. So what kind of a tolerance is it? Is it an unilateral tolerance or is it a bilateral tolerance? Anyone? Because the basic size is 30, maximum size is below, and minimum size also is below. So is it a unilateral tolerance or bilateral tolerance? What do you say, guys? Unilateral. Very good, Praveen. Very good. Because both are below. Only negative is allowed here. Very good, Praveen. Now, and hole is the basic size is of course this. It went the lower dimension is it is little below. Lower dimension came down. Upper dimension is 0 itself. Okay? In the sense, upper deviation is 0, lower deviation is negative. What is this? This also is a what? Unilateral, isn't it? Because 0, yes, good. Now, obviously, for tolerance of what is a shaft, it is upper minus lower, isn't it? The upper deviation minus lower deviation, and that is what is tolerance. Okay, upper deviation minus lower deviation is tolerance. Like that, for hole also you have upper deviation and lower deviation. Okay, so this diagram is a little bit confusing. It's not confusing, but let's go to the main diagram that people generally use. So that is what is basic size. Basic size is the 2 value. Actual size is what has really what do you say, measured after manufacturing. Zero line is the correspondence of basic size. That is what I told you already, right? and deviation is nothing but the algebraic difference between actual value and basic size. That is what is your error, deviation. Right? Upper deviation, I told you already, it's nothing but how above, what is the maximum it can go. And now the important thing that you have to remember here is that this one, that is ES and small es. Something is written in capital, something is repeated. Actually, ES means Ecart superior, right? Ecart superior, it's some language, I don't know. ES cut superior, and that capitals, that bolds, that capitals is representing a whole. If something is written in capital and it is written as ES, S is superior, then it is corresponding to whole. If something is written in smaller case, then that is corresponding to the shaft. Okay, and the same way EI is inferior, in the sense lower value, lower bound, lower deviation, lower bound, and capital of course is corresponding to the whole, and smaller is corresponding to the shaft. Okay, fine. Now, so if you see, this is the basic line, and if you are going above, both are above. This is your basic line. Both are above, in the sense the lower limit also is an above, upper limit also is above, but still ES, EI. This is what is the tolerance limit, tolerance gap, tolerance width. This is what is the width of tolerance, width of tolerance, right? So in the sense, like you thought of manufacturing 30, but the lower that you can manufacture was 30.1, and the maximum that you can manufacture was 30.2. That is what is your, and the width of tolerance is 0.1 here, and ES is 30.2, EI is 30.1. Okay, fine. And if you see, I told you already, this is your zero line. Okay, and with respect to zero, you should be able to do. So if this is hole, right, this is hole, and this is shaft, right? So how can I draw this? Okay, let me draw the diagram, then you'll understand. Hole is, the maximum hole is this. Okay. And the maximum shaft is like this, right? So you can do it in 2D like this, but they have cut it. They've cut it symmetric, right? So what I'm saying is that this hole is on top, in the sense you are, let us assume this is 30 and hole size is 30.1, or hole size minimum is 30.1, maximum is 30.2, and for shaft maximum value is 29.8, and the minimum value is 29.7. You take any dimension of hole in between this width zone, and any dimension in between this shaft, will it not fit? Is it going to fit or not? Is the shaft going to fit hole or not? Yes or no? Any dimension between 30.1 to 30.2 you take as a hole dimension, and shaft obviously is less, so obviously shaft will fit into the hole, right? So there is a different name for it. I'm not going to say that now. Okay. So if you are seeing in whole perspective, so this is your lower deviation from the basic size, and this is your upper deviation from the basic size. If you see it the other way, the shaft, this is the maximum value of shaft, so maximum. So that why these are ulta. So this is your maximum value of hole. This is your maximum value of shaft. So from zero line to the maximum value of shaft is upper deviation. From zero line till the maximum value is upper deviation. Okay, and if you are saying from zero line, we go to the minimum value. This is the minimum value of shaft, isn't it? And this is the minimum value of hole as well, right? So the lower deviation is this for the shaft, and the lower deviation is this for the hole. Is it clear, guys? Any doubt in this? Please make this clear. Guys, are you here? Yeah. Okay, fine. Okay, good. Now, so the minimum clearance is this one, right? The minimum clearance. If you're putting shaft, if you're taking maximum value of shaft and minimum value of hole, and then this is the minimum clearance. And if you're taking maximum value of hole, minimum value of shaft, then this is the maximum clearance, right? Is it clear? And this minimum clearance is also known as allowance. And you see the distance from basic size where the tolerance zone is suited is known as fundamental deviation, right? So this is your fundamental deviation. Okay, fine. So now that we got the terminology is known, let's go to the next one. That is your this thing. So systems. One is hole basis system, another is shaft basis system. What is hole basis and shaft basis? Let me explain. Okay. So if you take hole, okay, let me take pen only. If you take hole, you see the minimum size of hole is exactly equal to the basic size, and maximum can go up. And if you see shaft, the maximum value of shaft, is equal to the basic size. Here, minimum size of hole is equal to basic size, and here maximum size of shaft is equal to basic size. So that is the difference between hole. This is what is your hole system, and this is what is your shaft system. Is it clear, guys? And I told you already, something which is referring to hole is written in capital H, right? And if it is a shaft based system, then you'll write in a small h. Okay. So what I'm saying is that if you're writing capital H as hole, then it is a hole based system. Means this is a system that you have to follow. Compulsory, minimum value of hole has to touch with the basic line. And if you say I'm writing some H, it means that I'm representing hole as minimum this letter. It means that I'm using the shaft based system where maximum value of shaft is coinciding with the basic size. Okay, good. Now, this is where the fits come in. So till now we have discussed about limits and tolerances, but we haven't discussed about fits. There are three different fits, but before that we'll see that what is shaft basis and hole basis. You see, actually this is one kind of an what is the standards they are trying to follow. Okay, if you see all the letter starts from H, capital H, capital H, capital H, capital H, capital H, capital H. In the sense, capital H's are representing the whole. The small letters, whatever is writing in the small letters, are representing the shaft actually. Here. Okay. So if all the holes, all the minimum value of holes, hole 9, this H8, H9, I'll tell you what is H8, H9, but as of now understand. All the holes are the minimum value of the holes are touching the basic line. Then that's the reason why this is your hole basis. And if you see in this diagram, the maximum value of shafts, this shaft, every shaft are coinciding with the basic line. That's why this is called shaft basis system. Is it clear the difference between shaft basis system and hole basis system? Yes or no, guys? Hello? Yeah. Good. Now, and the hole is like this, shaft is like this. It means this is some fit. And if you go from left to right, your hole dimensions are increasing. You see, hole dimensions are increasing. Sorry, shaft dimensions are increasing, and hole dimensions are remaining like this. It's not coming down. In this case, shaft dimensions are like this. The baseline is like this, and hole dimensions are coming down like this. So what is that? I'll tell you. For that, you should understand this system. Yes, this is a system. Right? So if you see, A is hole, this A is shaft. This A is having some certain values of width of tolerance actually. That is what is your standard. If you take a capital A system, this says it is having some width of tolerance. This A also is having some width of tolerance, and also this is hole and this is shaft. So this, no matter what, if you're following this A system, then you have to take the minimum and maximum from a hole from this range only, and minimum and maximum and minimum value of shaft also have to be taken from this range only. Some ranges are fixed. I'll tell you what are the ranges. Okay. And like that, if you go from left to right like this, your tolerances are coming down, coming down, coming down, coming down. The capital letters, these are all capital letters. All are capital letters. All are capital, which is representing the hole. And these small letters are going up. They are all small letters. This is shaft. Okay. And somewhere at H standard, you see that this is your basic line, this is your hole, and this is your shaft. The minimum size of hole, maximum size of shaft are mixing here, and that too with the true value. This is your H system. If in exam somebody will ask you in H system, because this is the important thing that they'll follow. Okay, fine. Now so now we'll discuss about fundamental deviation. What is fundamental deviation? Fundamental deviation is nothing but it is one of the two deviations, either upper or lower, which is nearest to the zero line. Okay, so if you see the nearest value, you take the dimensions are like this. This is for hole and this is for shaft. Let's say. So you see the minimum. Let's say this is the distance something. This is some distance. Let's assume that this is 0.1 and this is 0.2. Let's say. So the minimum is this. So this is what is your fundamental deviation. Or sometimes the line is like this, and this is very near. The shaft is very near, and hole is little far. And the width is very far. This is your fundamental deviation. This distance here, fundamental deviation. Okay, that is very important, because with respect to fundamental deviation, first they'll give you the system, then they'll give you the fundamental deviation. From there you can calculate all the tolerances. Okay, fine. And there are 25 different fundamental deviations. That is what is A fundamental deviation, B, C, D, E, F, G, H, I till Z. What is that? Any of two. Yes, any of two, Praveen. Any of two. You can take hole and shaft both compulsory of two. Yeah, hole or shaft. Any you take. Just this diagram is here like this. I'm randomly drawing. So here the minimum is this. That's it. Fundamental deviation. That's it. Okay. Is it okay, Praveen? Okay. And like this, we have 25 fundamental deviations. So here I told that width, right? Instead of width, the fundamental deviations are very important. Right? Like that, we have 25 fundamental deviations. Any information in capital represents hole. Any information in small represents shaft. That I already clearly mentioned. Okay. If you're taking A type of hole, then I told you already you have to take off. You should take A type of shaft. compulsory. Okay, fine. Now, bilateral tolerance, I told you, it is like maximum limit above and minimum limit is below, right? And allowance, I told you already the difference between, okay, so you should understand the maximum material limit. So to understand the maximum material limit, what is a limit, if I'll take two things, smaller hole size, bigger hole. In terms of shaft, smaller shaft, bigger shaft. Case 1 in hole, case 2 in hole, case 1 in shaft, case 2 in shaft. So this is case 1 and case 2. This is for hole, this is for shaft. In the first situation, in the hole situation, who is having more material, 1 or 2? Asking a question. Who is having more material? Is it 1 or 2? Who is having more material? This is material, right? This is material. And this is material. 1. In the sense, maximum material limit will come with minimum hole size, isn't it? Maximum material limit will come with minimum hole size, isn't it? If you have minimum hole size, then only you'll have maximum material. Is it right or wrong? Yes. If you go into second case, this is a material. More the shaft dimension, more the material, isn't it? In this case, 2 will have more material. Am I right? Yes. So that is the reason why the maximum material limit is termed as maximum shaft size. Maximum shaft size, that is what is this thing, or minimum hole size, that is what is. Is it clear now? What is the maximum material limit? Yes. Fine. Now, it is a difference. So now we'll discuss about elements. Elements is nothing but it is a difference between. It is a difference between maximum material limit of hole and shaft. Maximum material limit of hole and shaft. Maximum material limit of hole is the minimum hole size, isn't it? Yes or no? And maximum material limit of shaft is bigger shaft. The difference between these two, this dimension, that is your maximum shaft size, and the minimum hole size, the minimum hole size is your allowance. Is it clear or not? So that's the reason why maximum shaft size, minimum hole size will give you allowance, and that is what is your maximum interference. Why it is called interference? Because you have minimum hole, maximum shaft, so this can't go. This shaft will interfere, it can't go, right? In the other case, I can say minimum hole size, right, minus maximum shaft size, right? It is reverse. Minimum hole size, minimum hole size is this. Minimum hole size is this is the maximum hole size, and maximum diameter is this. Minimum diameter is this, and this is what is full it will go, and this is what is left. That is what is your clearance. Okay, I'll tell you what is the clearance. Now, what is allowance? Either it can be a maximum interference in the case of interference, or it will be minimum clearance in the case of clearance. That is what is your allowance. Is it clear? The difference between maximum interference and minimum clearance and allowance? Yes or no? So to explain this very nicely, what I'll say is that, okay, you understood? Okay, then it is fine. Very good, sir. Very good. Okay. Now we are going into the fits. Very important. What is that? We have 3 different fits: clearance fit, interference fit, transition fit. What is that? Okay. Clearance fit. When it will come? When it will come clearance fit? My hole maximum value is this much. Okay, I'll tell you. I'll draw in different colors. Then it'll understand my hole. Okay. Okay. Maximum hole dimension is this. Okay. And minimum hole dimension is this. And my shaft, maximum shaft size is this. Minimum shaft size is this. Okay. So this is the maximum shaft size, minimum shaft size. So this is for shaft. In hole, this is the maximum hole size, minimum hole size. Hole. You take any dimension of shaft and any dimension of hole. Will the shaft fit? Okay, not on the second previous. It is second. Is it minimum hole size or maximum? It's minimum hole size only. I'll tell you. Minimum hole size means the example for this and example for this is different actually. So this will come in the clearance fit actually. This will come during clearance fit and this will come during the interference fit. I'll tell you. I'll come back to this slide again. Okay. Is it okay? Okay. Is it clear, Praveen? I'm not getting any response. Are you here? Yeah, we have, obviously, we flipped only the terms, but this is interference because this is interference fit. This is clearance because this is clearance fit. So first we'll understand interference and clearance and then we'll come. Is it okay? Okay. Okay. Now, this is the case one. So let us assume that this is some 30.1 and the maximum is 30.2 and the maximum size of shaft is some 29.2 and the minimum size of shaft is 29 itself. Now you tell me, take any dimension of shaft and any dimension of hole. Is the shaft going to fit in hole? Yes or no? Is the shaft going to fit in the hole? That is what is question. Yes or no question? What do you say? Take any dimension of shaft and take any dimension of hole from the tolerances, from this tolerances I've already mentioned. Yes, all the time it will fit. All the time it will fit, right? All the time it will fit. You're right. Now take the maximum shaft size and minimum hole size. What is the maximum shaft size? Maximum shaft size is 29.2. Minimum hole size, this is your maximum shaft size. Minimum hole size is 30.1. This is minimum hole size, right? And the difference between these two is what? Some 0. Is that 0.9, isn't it? 0.9, right? Yes or no? And that 0.9 is the maximum clearance or minimum clearance. Is it not minimum clearance? That is what is the minimum clearance, no? That is what is minimum clearance. This 0.9 is minimum clearance. Is it clear or not? Minimum clearance. When it will have maximum clearance? When you are selecting minimum size of shaft and maximum size of hole, then only the maximum clearance will come. But I'm selecting the maximum shaft and minimum hole. That's the reason why I'm telling this is minimum clearance. In both the cases, you take any dimension, clearance will be there. Is it true or not? Are you getting? Yes. Now, say Praveen, in the previous slide, I told you that minimum clearance is minimum hole size maximum minus maximum shaft size. Minimum hole size minus maximum shaft size is minimum clearance. Now is it clear? Now the doubt is clear or not? Yes. But if you flip the terms, it will become maximum interference. I'll tell you. But I should tell you the. I'll tell you the interference. So in this case, clearance is nothing but you take any dimension of hole, any dimension of shaft, it will have some clearance. There is some clearance that is left. Okay. But let's see the interference width. This is the hole, maximum hole, minimum hole. Let me take minimum hole, maximum hole, minimum shaft, maximum shaft. This is hole, this is shaft. Now this is what is your width of tolerance. This is what is your width of tolerance, right? Width of tolerance of shaft and hole. Right? Now you take any dimension of shaft and any dimension of hole. Will the shaft going to fit in hole? Will the shaft going into hole? Yes or no? Take any dimension of hole. No. Why? Because you take maximum hole size, right? And minimum shaft size, it's not going to fit because this will interfere. This whatever minimum, because bigger shaft and smaller hole, it can't fit. Now what I'll do is that I will take. Now I'll take uh, minimum shaft, right? Minimum shaft or maximum shaft? Yeah, minimum shaft. And I'll take maximum hole. Okay, but no, I should take the ulta. I think 1 minute. I'll take the ulta. This is shaft. This is hole. Okay. Hole I'll draw a little smaller. Wait. What happened? Come on. Where is the cursor? Okay. I'll show you here. Okay, I'll show you that interference. So that is what is interference. Okay, I'll tell you that. This thing I'll tell you in the coming slides. Okay. Okay. Clearance fit and interference you got. Transition fit is nothing but you take any some combination of hole and some combination of shaft, then it will fit. Some combination of hole and some combination of shaft, it won't fit. So that is what is your transition fit. So to understand that, you have to see this clearance fit. So you see here, this is the hole, minimum hole size, maximum hole size, maximum shaft size, right? You take and it will going to fit. It will every time fit into that, right? What happened? Come on, my laptop is not responding. One minute. Not responding, please. Okay. I should wait. If I close, the full system will go. Okay, I think it has come back. This is so. If you see, you take any dimension of hole, you take any dimension of shaft. Okay, but if you see here, hole is below now. Hole is below. You take hole size is very small, but minimum dimension of shaft is very high than the maximum dimension of hole. Right? That's the reason why this is the minimum interference. Is it clear or not? So this minimum interference. Okay, and this is your maximum interference. Okay, fine. It's not responding. Okay, fine. Yeah, good. Now, next, interference fit is like this. What is interference fit? What is interference fit? If you take this hole size and this shaft size, it's going to, is it going to fit or not? If I take this hole size and this shaft size, is it going to fit or not? Fit or it won't fit? It will fit, no? Praveen, will it not fit? Hole is bigger, no? Hole is bigger. Bigger hole, smaller shaft. Going to fit, no? Yeah. But if you're going to take this shaft and this hole, this hole and this shaft, not going to fit, right? So sometimes it will fit, sometimes it will not fit. That is what is your interference fit. That's it. And next, what I'm going to discuss is nothing but calculation of tolerance and fundamental deviation. So fundamental deviation, I already told you, the minimum value on both the sides, isn't it? The minimum value on both the sides for hole and shaft. That is what is fundamental deviation. Didn't I say? Yes. Now, this fundamental deviation can be calculated by this value. For what is this D, sir? D is nothing but geometric mean of upper and lower and upper size of the dimensions in steps. This is what is D. They will give you all this D1, D2 will be given in examination. It is based on some standard, what do you say that rule books, or maybe they'll say that what is that? What they'll follow? No? What is that book? Books they'll follow. That guidelines will be there, no, in the companies. That book. Okay. So if D1 and D2 are given, then you calculate the geometric mean of that, and that geometric mean you substitute into this D, and then you get this fundamental deviation known as, or standard tolerance is also known as I, and it's known as standard tolerance limit. And I told you already there are 25 ways, but in that 18 grades there are 18 standard tolerances. IT is international tolerance 1, 2, 3, 4, 5, like that. We have 18. In that, we are not going to use from IT1, IT01, IT0, IT1, IT05, but you will use from IT5. So what is the IT? All things we'll see here. So this is what is IT5. In the sense they say IT5, if you they're mentioning IT5, then you have to use your standard tolerance as 7I. I you are calculating from this formula. I you are calculating from this formula. And if you are saying it is IT6, then you use 10I. Like this, all the things you have to calculate. And the fundamental deviation for this empirical formula is this. Fundamental deviation is this. Okay. So this is how you are calculating standard tolerance, and this is how you are calculating the fundamental deviation. Epsilon. Right? Now, tolerancing. If you see here, this is hole type. Why it is hole type? Because there is a capital H here. And this is a, what happened? Again, my system got stuck. Huh? No. Okay. So this is your shaft type. Why? Small letter. Okay. And this is a fit. Fit in the sense it will say hole and shaft. Okay. But this 8 you are saying, this 8 you are saying is your tolerance grade. That is what is your IT8, IT8. Okay, and the H, what you are saying is your fundamental deviation type. We have seen now that H type. This is what is here. This is what is your H type. Okay, that is for hole. And this is your shaft type. IT7. 7 means IT7. IT7. What is the standard tolerance? 25 into I. Okay, and for fit, this is for shaft. So this is for hole, and this is for shaft. And 8 and 7 are corresponding tolerance grades. Okay, IT represents international tolerance. Right. Now there are some questions, but I'm not going to solve them here. I think that's it. That's the end of your limits, fits, and tolerances. Okay, fine. Let me close this. Wait for 1 minute. I will give you very brief intro in material science, and then I'll stop and I will discuss something on what you say, how to go about examination and how to spend the rest of. And I think you have 2 weeks, isn't it? 2 weeks, right? You have only 2 weeks left. Am I right? Yeah. So in these 2 weeks, you should not touch any new topic. You should be able to solve what happened. Come on and close this. PPT is not at all responding. Let me stop sharing. Is the screen visible, guys? Hello? Okay. I think, is it, am I audible at least now, guys? Okay, good. Let me share the. One minute. I'm sharing the material science, but I don't know why my computer is not responding. Wait for 2 minutes, guys. I think my system is not responding and it is not opening the PDF because material science notes is in PDF. Give me 2 minutes. I'll don't go away. I'll come back. Can you see the notes, guys? Okay, good. Okay, good. So now material science is very big. You see, you have 86 pages here. I don't know why my Adobe PDF reader is not working. So I have opened in simple web browser. Okay. So if you see here, it is having so much math syllabus. I'm not going to discuss all the things. I'll tell you some basics only. So you have all these phase diagrams. Okay. Now all the things. This notes has been written by one of my friends. Okay. This has been written by one of my friend, and I think he is somewhere in Bark now. Yeah. And when he was preparing for engineering service examination, he has written it. So it was a very good notes. So I've taken it, and I asked him for Xerox. He has given it. That's it. Okay. It's very good notes. So let me go to the main crystallography. Okay. That is very important. Okay. Before going to that, let's go to the heat treatments. There are different number of heat treatments. I'll explain the heat treatments and then we'll go to the crystallography. Because heat treatments are very highly asked questions in the examination. So heat treatments. Okay. In heat treatment, if you see, what is that? You heat it and cool it. That is what you're going to do. Simply you heat and cool it. But how much time you're heating, till what temperature you're heating, how much time you're cooling, till what temperature you're cooling, where you're cooling, in which fluid you're cooling, air cooling, liquid cooling, which liquid you're cooling, heating and cooling, heating and cooling. Everything is important. That is what is heat treatment. By doing this, your material properties are changing, and that material property change is very essential in the case of machining or maybe some kind of what you say property achievement. If you want to achieve some property, then you have to do this kind of heat treatment techniques. Okay? The combination of heating and cooling operations timed and applied to a metal alloy in solid state in a way that will produce desired properties. That is what is the meaning of heat treatment. Right? So annealing is first one, right? And normalizing, hardening, and tempering. If you are discussing all these four, that's enough. That's the end of your material. What is heat treatment? Material science heat treatment. So what is annealing? So I'm not going to discuss. There are so many annealings. There are so many normalizing. I'm not discussing everything. I'm telling the basics. What is that? Annealing refers to a heat treatment in which a material is exposed to elevated temperature for an extended period of time and then slow cooled. Very important. It is slowly cooled. Sometimes it's also known as furnace cooling. Where do you do this heat treatment? Where do you heat this item? Where do you heat this material? You heat the material in a furnace. Right? What you do? If you go to any manufacturing plant, you have a furnace there. Then they'll take that object and they'll put it into that. Okay. Now what they'll do? They will increase the temperature of furnace for a certain period of time. Then they'll switch off the furnace. It means that no heating is not happening. But the cooling will be slow. Right? Let us assume that you cooked some food. In a utensil. And if you are placing the lid on the utensil and you are not placing the lid on utensil, will make a difference, right? In the same way, you are not opening the furnace, you are keeping like that only. So it will take longer time to cool, slowly cool. So by that, what will happen? These are the properties that are achieved. What is that? Relieving stress, increasing softness, in the sense harder materials are converted into ductile materials. Okay, harder materials are converted into ductile materials, and the materials is becoming tough and produces a specific microstructure. So annealing will do, mainly it will do relieving stress, then increases the softness because of the slowly cooling. No, it will increase the softness because the temperature gradients are very less. Because of that, coarser grain structures are formed. Because of coarser grain structures, the material is softer. Okay, and then we have full annealing, all the things you forget. Next is normalizing. What is normalizing? Samples are heated to a temperature above upper critical temperature line. The upper critical temperature line will come in TTT diagrams, time temperature transformation diagrams, but I didn't discuss that. If you know that, you will understand this is what is upper critical temperature line. If you are crossing that line, followed by cooling in still air, in the sense it's not slow cooling, it's fast cooling only, because you are heating it in furnace, you are switching on the furnace, you are removing the object and putting it still air or putting it in your ambience. So in the previous case in annealing, you are cooling it in furnace itself. You are switching off the furnace. First furnace, slowly furnace will cool, then only the object inside the furnace will cool, slow cooling. But here you are cooling it in still air. Okay, so that is what is normalizing. Okay, the purpose of normalizing is to produce harder and stronger steel than full annealing. In the reason for normalizing maybe final, the normalizing will be a final heat treatment because you are making the structure hard, in the sense you can't machine it, you can't machine the harder surfaces. But after normalizing, your structure is becoming hard, in the sense it's the final process of your complete manufacturing. I mean, you are hardening it, that's it. Okay? So what I'm saying is that here, as the cooling rate is very high, finer grain structures are formed. Because of finer grain structures, the hardness is increasing in the case of normalizing. Please remember, annealing, softness is increasing. Normalizing, hardness is increasing. Annealing, slower cooling or furnace cooling. Normalizing, faster cooling or still air cooling. Ambience, you are just removing it. Okay, that is the difference between normalizing and what do you say, the annealing. Next is hardening. Steels are heated to a temperature at which austenite is stable. So this austenite and all didn't discuss, but forget. But remember, memorize it. Okay. And the sample is quenched in the sense cooled at a rate of higher critical cooling rate. Okay, that is hardening. Quenching, it is nothing but you are putting the liquid, the item in some kind of a fluid. You might have seen, right, in movies also you might have seen some heated object will be there, then they'll dip into the liquid, then it will produce some fumes, right? It will cool faster. That is what is your quenching. Okay. And the other one is nitriding. Where is that? So very big notes. Carburizing, nitriding, cyaniding, flame hardening, induction hardening. Okay. Carburizing. What is carburizing? If I want to make the material harder, I have some material, I want to make the material harder. What will I do is that I will take the material and I will put it in some kind of high carbon environment. You see? Carburizing. Carburizing is the process of diffusing carbon into low carbon steel, which is placed in atmosphere that contains substantial amount of carbon monoxide. You are putting this material in the carbon environment. How do you put carbon? You are having carbon monoxide around it. So the carbon will be diffusing into the material that you have placed. As the carbon is diffusing, what is happening? The hardness is increasing. Okay. And then you have so many type of carburizing. Forget about that. Then cyanide. Cyanide also is one of the way to improve the hardness. There you used carbon monoxide. Now you are using cyanide for carbon. But this is very dangerous, and because cyanide is very toxic in nature. Okay. And next is nitriding. Instead of putting it in carbon environment, you are putting in nitrogen environment. There carbon is important, here nitrogen is important. So who is having nitrogen? Ammonium gas. Ammonia gas is having nitrogen, NH2. NH3, sorry. Right? So if you're putting your material in a ammonia gas environment, then nitrogen will be diffused into your component, and it is increasing its hardness. Because carbon and nitrogens are the important materials or important these things are elements are diffused into the material to create hardness. So nitriding is giving good hardness, then cyaniding, then carburizing. Please remember this. Nitrogen is having bigger atom size, right, than the carbon, right? Bigger atom size, so more hardening. Nitriding is having more hardness than cyaniding, then carburizing. Okay, fine. Now flame hardening. Flame hardening is nothing but you're using oxyacetylene, you're heating it, and you're suddenly cooling it. Flame hardening. Induction hardening is nothing but you're heating with the help of magnetic coils and cooling it. That's it. Okay? That are differences. But why I told all these things? Because some basic questions will be coming. Annealing and normalizing are very basic questions. I'm again I'm saying annealing, low cooling, softer material. It will lead to softer material. And the other way, normalizing will lead to the harder structure, faster cooling, means still air cooling. Furnace cooling also is known as annealing. Please remember, again and again I'm saying. Okay. Next is crystallographic structure. The crystallographic structures are having, like, you can arrange the atoms in different fashion, right? Crystalline structures. Amorphous is not having any order, but crystalline structures are having some order, right? So that is what is arrangement of atoms. How you are arranging? So you have to arrange in some fashion. In that arrangement, you can take a unit cell, the smallest unit having the full symmetry. So you take the atoms arrangement, and then from that you take a symmetry out of it. That smallest unit of symmetry is known as unit cell. Okay, and then you have different structures based on this unit cube. So you have dimensions A, B, C. These are the dimensions of your cube. Lattice, this is lattice, and alpha, beta, and gamma are the angles between two different axes. Alpha is the angle between x and y and z, and beta is the angle between x and z. Gamma is the angle between x and y axis. That is your interaxial angles. So based on these things, like if A is equal to B is equal to C, if alpha is equal to B square, beta is equal to gamma, then it is simple cubic structure. Simple cubic structure is having simple cubic, and this is what is this is cubic actually. In that we have simple cubic, body centered cubic, and face centered cubic. Okay. Then if your A is equal to B, this is not equal to C, then it is called tetragonal. In that we have simple tetragonal, body centered tetragonal. Like that, hexagonal, simple hexagonal, orthorhombic. Like that, we have so many structures based on the geometry, that is A, B, C values, and beta, alpha, beta, gamma values. But mostly we concentrate on cubic, that is simple cubic, body centered cubic, face centered cubic, and also one more extra, that is simple hexagonal. We'll discuss this. Okay. So for simple cubic, SC, what is that simple cubic? This is the structure of simple cubic. That is, you have a simple cube, and in this A, B, C all are equal. Alpha, beta, gamma are 90 degrees. In that, at each corner, you put an atom, and this will be the top view. And you see this radius are touching this. And then this is the top view. That is what, if you see the cube as a top view, you get as a square. And this is how the arrangement will look like. And if you remove the outer one, in that this is where the complete cube is there inside. So the complete atom is there. Okay. So in this you have to remember some important points. What is that? The number of atoms per unit cell. So in this, 1/8 of the corner is inside the cube, and rest of the things is outside. 7/8 is outside. 1/8 only is inside. Like that, 1/8 in this side, this corner, 1/8 in this corner, 1/8 in this corner, 1/8. All the 1/8s will be inside the cube. How much is inside the cube is your number of atoms in the cube. So there are 8 vertices, right? 8 corners. 8 corners into 1/8 of each atom is inside. So that's why 8 into 1/8 is 1. So this complete atoms sharing inside the unit cell is corresponding to 1 atom. Okay. And another thing is coordination number. Coordination number is nothing but it is the number of nearest and equidistant atoms surrounding an atom under consideration. It means that you take this atom. How many nearest atoms are there? 1, 2, maybe top 4, like that. 2, 3, 4, like that. How many nearest atoms are there? If you take any atom, how many nearest atoms are there? Count them, and that is what is your coordination number. In the case of simple cubic, you have 6 number of nearest atoms. Why? Because if you take this atom, 1, 2, negative 3, top 4, 5, bottom 6. Like that, you have 6 nearest atoms, because this is negative, this is near, but this is not near because this is diagonal atom. For this atom, this is diagonal, right? Like that. And next is atomic packing factor. Out of this total cube, how much is atom, how much is space, right? So the total volume of atoms divided by the volume of unit cell, total volume, right? The total volume of atom, so already told it is only 1 atom, right? The simple cube is 1 atom. 1 atom circle is a sphere, 4/3 pi r square, pi r cube divided by a cube. And you are converting this side A in terms of this radius by A is equal to 2r. Here this is the geometry. Then if you are substituting this 2r square, 2r whole square, whole cube here, and then if you are seeing, this is what is your 0.52. So the atomic packing factor, how much of atoms is inside the unit cell, what is the percentage of volume of atom inside the unit cell is known as atomic packing factor, and that is given by 0.52 in the case of simple cubic. Body centered cubic, the structure is like this. All corner atoms are there, but this big atom is at the center of cube. And in this case, number of atoms is already we have done 1/8 from each corner into 8 into 1/8 plus one big atom is in between plus 1, that is what is 2. So number of atoms per unit cell is 2 in the case of body centered cubic. Body centered, full body center one atom is there, that is what is body centered cubic. And coordination number is 8 because 8 nearest atoms are there, and atomic packing factor is given as 0.68. there it is 0.52. okay, and here it is 0.68. And then for face centered cubic, what is face centered cubic? Each face, half of the atom is shared. This face 1/2, in this face 1/2, on that face there are 6 faces, 6 into half, right? So already 8 are there. 8 into 1/8 plus 6 into 1/2 will give you 4. So total number of atoms inside the cube are 4, and coordination number is 12. Nearest atoms are 12 in this case of FCC, and atomic packing factor is 0.74. okay, so and hexagonal structure is like this. We have hexagons like this, 6 hexagons, below 6 hexagons, top in center 1, bottom 1, and between this is kind of a structure. This full is your hexagonal structure. In this, the total average number of atoms is 6, atomic packing factor is 0.74, and coordination number is 12. It is very difficult to analyze this, but you have to remember the values. So what we have seen: simple cubic, body centered cubic, face centered cubic, and hexagonal. In these things, what are the important factors you have to remember? Average number of atoms you have to remember, atomic packing factor you have to remember, and coordination number you have to remember. What is coordination number? You take any atom, how many number of nearest neighbors, how many nearest neighbors are there? That is what is your coordination number. So with this, I'll close the session for complete manufacturing and industrial these things, because as we keep on moving, there is so much syllabus. At least we have to, for gate also, I'll take approximately 80-90 hours to complete gate syllabus. But with limited 30 hours of time, we are forced to do in a very fast track. We have to do very faster than the gate way of dealing it. So anyways, let me stop these things, because I will discuss something extras from now. And if you have any doubt, please ask me. If not now, we can ask me in the group as well. Even after your examination also, you can message me up for any personal issues. I'll be able to respond wisely. Okay. Anyways, so thanks for attending. I will. Did any one of you have asked Dinesh sir for the note sharing? Anyone? Guys, did he allow? Guys, please, you ask him. Let me know if he's very he's actually saying that share and sharing. Okay, because as I told, it is difficult for you to buy from lectures, but I don't know, because it is a free or free lectures. I don't know what he's thinking. We'll see that. Fine. So ask it. Yeah, after this class you can ask. So now comes the important part. But I'll discuss. I told you I'll discuss in the final. So we are left with some 20 minutes, right? So one thing that you have to remember is that everything that we are going to try in our life is for our good, livelihood, life in ahead, right? Sometimes we might fail, and sometimes we might get succeeded. Sometimes we might put some hard work, but we will be failed. Sometimes without doing anything, due to luck, we'll be succeeding in it. We don't know what's going to happen. The only thing is that according to me, we have to work hard. Only hard work will pay. Because not now, somewhere else it will be useful. Okay. So with this, what I'm saying is that you take anything, be it HAL, be it GATE, be it something else that you want to work on. The only thing that matters for me is hard work. Even though we are very intelligent, we are not intelligent, we are dumb, it doesn't matter. Do the same thing again and again, again and again, again and again. You will become professional in that. You will become pro, and that will be very useful. And sometimes it might be the best what you say skill that you have, and nobody is having. Okay, so that is one. And two, coming to HL examination, I think you have some aptitude, you have math. Do you have math in HL? I don't remember. Do you have math also in HL examination, guys? Okay, yeah, fine. So you have aptitude, you have math, and you have technical part. So how to attempt this exam, HL exam? First, you have very small questions, conceptual questions, and more number of questions, right? And limited time. I think if you have 3 hours, I think you have 160 questions. Yes, I think 160 questions, isn't it? 160 or 180 questions, I don't remember, something like that. Approximately for a single minute you have to write one question, approximately. Yeah, for a single minute you have one question. So you can't stumble upon one question and keep on doing that same question for 5 minutes. It means that you lost 5 more questions. So if I were you, what would I do? This is what I will do. Number one, I will scan the question paper from top to end. In the sense, I will go to the question, whether I can do it, put some answer. Next, whether I can't do it, don't even look at that question. Go next. Whether I can do it, yes, tick. Next, I'll do. Fourth question, I can do, tick. Fifth question, oh, it will take some time. No, next. Even though you know how to solve the question, don't do that. Calculation might be intensive. Wantingly, he'll put that kind of questions in initial stages because he wants to filter the people. You might know everything, but you couldn't solve the question paper in time. Right? That is what is your smart people will do. So you fastly scan 1, 2, 3, 4, 5, 6, like that. Keep on scanning it. Then in one scan, out of 160 questions, you might have answered some 30, 40 questions, which were very easy. Yes, no negative marks is dangerous. Luck will be having more probability now. People who are randomly they'll put if it is right. What can we do? We can't do anything. Okay, so scan it. In first round, let's say you solve some 40 questions, 30, 40. And then the second round, you should see which are very less calculation intensive, or the concept that you think that in the first round, obviously you'll keep questions which are very easy to answer, right? Second round, what you have to do, some concepts you have to think, some logic, some tricky questions are asked, so then you have to think. Then think that questions, and then very less intensive calculation questions will be answered. Then second round, you might be answering some 50 more questions. Then this will give you approximately some 40 plus 50, 90 questions you solved it. And third round, then there is no other option. You have to scan everything. You have to keep on doing everything. Like that, you might be answering around 120, 130. No, 120, 130. That is what with your will, or that is what with your mind. And some questions will be left. Obviously, as there is no negative mark, then what you have to do, you have to choose wisely, aptly. Don't keep it fluke, A, B. That is bad. Aptly, wisely you choose. Okay, this most probable that this might be the right answer. I feel that this is the right answer. Like that you complete paper, and then you have to come back. Please check whether there is negative mark or not. I don't know. If there is a negative mark, you can't attempt all the questions. If there is no negative mark, then you can attempt all the questions. Okay. And Another thing is that, okay, fine, somehow you cleared the exam. Second thing comes your interview. In interview, these lectures are important. You know why? They won't be asking any questions. They'll be asking all the concepts. They'll ask you, can you explain the procedure of investment casting? Then you should be able to say, sir, there is a metallic pattern, a metallic die in that we'll inject wax, then we'll form the wax pattern, and then we'll form a tree of wax patterns. Then we'll dip into the slurry, and then they'll re-dip into the slurry and dry it so that some certain shell thickness is achieved. Then we'll heat it into the oven so that the wax will drain out. Thereby, we are forming some kind of a cavity. In that cavity, we are allowing our liquid metal to flow, and then we are allowing it to solidify. Then we are breaking the shell, and then we are removing the each part individually from the tree. So this way you have to explain them clearly. Again, you can revisit some of the lectures which are very conceptual in nature. Okay. So, and in the final thing, motivation, because I think who are attending this HL examination should have, I think it is having some age limit, 28, I don't know how much, 27, 28, I don't know. It means that you're not too elder, you're in your mid 20s, right? So you have lots and lots of scope in the future, right? So every time you motivate yourself, self motivation is very important. Even though I'm telling some words, it might not reach to your mind for some, it will reach to your mind for sometimes, again we'll forget. But self motivation is very important. Daily morning, wake up, think what I'm going to do today. I should do something good. I should do something valuable. I should do something which is helping me in my future. Then at the end of the day, you have to think, did I achieve what I was planning in the morning? Right? If not, that should lead to the motivation for the tomorrow. It means that today I didn't do, tomorrow I have to do. Like that, write a schedule. Don't think in mind. You should write something from morning, what I have to do, afternoon, what I have to do, evening, what I have to do. Even for eating, for extracurricular activities also, you have to spend some time, limited time. You should not go beyond that. Okay, make schedule, prepare properly. Any exam that you are planning for, HAL, engineering service examination, GATE examination, any private organization, you are giving an interview, you are letting some, if you are learning some coding, whatever it is, have some schedule. Yes, like a journal you have to put, you're right. Maintain some book. Take a book, date, that day, plan. At the end, leave some space. Did you do that? Yes or no? Tick mark. No, red mark. Tick in blue, red, cross in red. How many crosses I did? How many ticks I've done? Slowly, slowly improve. Today, you did very bad. 10 days after, you did something good, some good ticks. Over the period of time, you achieve, you practice it a lot, then you can manage your time. Time management is very important because in this digital era, we have so many distractions. Mobile, laptop, so many distractions are there. So try to minimize all these distractions. Distraction will be there. Obviously, will be there. Even I also will get distracted. I mean, I'm not a big this thing. I'm a human, right? So obviously, I'll also get distracted. So you should find your way to avoid this kind of distraction. I mean, minimize your distractions. I won't say avoid, minimize. Okay. Work hard. Only one thing. Work hard. That's it. And please don't believe anything right away. First ask why. Ask why. Is it true? And if somebody is saying some concept, first question is that should come into your mind is why that is happening. First people will say what is that. Then you should question yourself why. Why? Let's say in material science, I told you just now. I told annealing, slow cooling will give you tactile structure. Why? That why will lead you to so many answers, and it'll try. You can try to explore the subject in a deeper way. If you're in mechanical, if you want to learn good mechanical stuff. Yes. Okay. So with this motivation, small motivation, I like you to say thank you for you to listen all the classes, attending all the classes. I mean, I would like to mention Guna, Praveen, Naveen, Prabhakar, right? All this. If I think I mentioned 4 or 5 names. There are some other people as well, but you are very consistent in attending the classes. Means you are very serious, prepare hard, and also one more thing is that um, this videos what you are uploading. If you are trying to uh, what you say listen again, if there are any mistakes that I made in the videos, please let me know so that I'll be able to correct myself. Okay, because I am also human, I'll also make mistakes. So if at all you are finding some mistake in the videos, please let me know. Then I'll be able to correct myself in the next turn if I'm explaining some other students. Okay, I should also improve. Every time I'll be improving. Every batch I've been teaching this from past 5 years. Every batch I'm improving myself as well. Right? Okay. So with this, I'll say only one word: all the best. That's it. Thank you. Thank you so much, Guna and Praveen. And you can meet me in the WhatsApp group and we can discuss there itself. And problems, I'm sharing some questions to, yeah, please ask me, Praveen. So I'm sharing some questions with your Dinesh sir, and he'll be able to conduct some examinations. So please try to attempt them seriously and try to prepare accordingly. Yeah, what is your doubt, Praveen? See, engineering service examination and state service examination questions are almost equal, but engineering service examination questions, no, they have some questions are very trickier. State level questions, I'm not sure. And engineering service exam questions are in a good channel because they are prepared by some experts, good experts. But state level examination, I don't know. Sometimes I feel some people are preparing it. Questions are very off. We feel that like this is some questions which need lots and lots of experience. But I'm not criticizing it. But what I'm saying is that it's my feeling. I feel that engineering service examination questions are having some channel, and if you solve them, you get good concept. That's what I feel. Than the state, but you should solve all of them because we don't know which kind of questions are coming, right? Try to solve as much as possible. That is the only way. Any other doubts? Lot of previous prelims, CSE. Yes, that's enough. What I'm saying, no, I've been saying from initially previous year engineering service objective question papers. That's it. Yes. Try to take, solve, see the solution. If you are unable to understand that, write that concept in a book, short notes. I told you, no, you have to maintain the short notes. Good source, I'm not sure. You have to buy some books online, like good publications. What is it booklet? Is it from any good institute outside? Like there are so many engineering service and gate institutes outside, right? Like some famous institutes, made is like that. So you can buy some of the institutes book which are having good ratings in online. Go to Amazon or Flipkart and see. Yeah, made is also fine because the collection is good. Like that, you can try to see some books and try to buy them. Yeah. But some of the solutions that are mentioned in these kind of books, no, they are wrong. Some of the solutions are wrong. Don't believe them directly. If you feel that solution is not it's not appropriate, then you go and search your concept and try to find out your solution. Okay. Because for engineering service examination, they won't release any official key. Like GATE, no, they won't release any official key. That is the problem. Okay. Any other? Yeah, you can stick to anything. I mean, you can select anything. I am not saying a specific institute, but you can select whatever you're saying. It's okay, fine. You can select that book and you can practice. Good. Yeah. Any other? Any other doubts? Sir, after HL exam, would you be able to do? Yeah, fine. Yeah, sure. I'm very bad in chatting. You can just call me up. Then if I'm not taking also, I'll call you back. Then we can have discussion. Yeah. With chatting and all, I'm not very good in that. Yeah. Fine. You can sure contact me. Yeah. Sure. Okay. I think you have another class. So let me wrap this up. And again, all the best for your preparation and as well as for the examination. Prepare well, perform well, possibly get into the HL. Okay, fine. Bye.